Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have only one integral to look at. It's the integral of sine inverse of x all over the square root of 1 minus x squared dx. Now the approach is as follows. Taking us to our first page, page 1, and the integral is the integral of sine inverse, some people say arc sine, of x all over the square root of 1 minus x squared dx. Now how we approach it is as follows. We let theta be equal to arc sine or sine inverse of x. Now you'll agree with me that this equation implies sine of theta is equal to x. Now let's define theta straight away in a right angled triangle as follows. And if this is our theta, you'll agree with me that sine is actually the opposite over the hypotenuse, so you can write x as x over 1. So sine will be the opposite all over the hypotenuse by definition. And using Pythagoras theorem, this side here will be the square root of 1 squared, which is 1 minus x squared, like that. Now from this equation here, we obtain another equation by differentiating both sides. So we're going to say the derivative with respect to x of sine theta, the answer must be equal to the derivative with respect to x of x. Remember, that's the equation we're focusing on. Now we have to use chain rule on the left hand side because we have sine theta. So derivative of sine is cosine, so we have cosine of theta here, and then we have d theta dx. And derivative of x with respect to x, the answer is 1. Multiplying both sides by dx, you're going to get cos theta d theta, and this will be equal to dx. Fantastic. Now this integral can be transformed as follows. The numerator must be replaced by theta. In the denominator, I'm going to have 1 minus sine squared of theta. Remember, x is equal to sine theta, so we have to put sine theta here. And dx will be replaced by cos theta d theta. As follows, taking us to page 2. Let me remove this page here. Page 2. What we have is that integral changes to the integral of theta in the numerator. Like I said, in the denominator, we have the square root of 1 minus cos, minus sine actually, square root of theta, and then we have cos of theta d theta. Remember what I told you? In the numerator, we must have theta there because theta equals sine inverse of x. In the denominator, we have 1 minus sine squared of theta, and then cos theta d theta, because dx is should be replaced by cos theta d theta, like so. Now at this stage, I want to remind you of one of the basic trig identities, which I have spoken about in the previous videos, which basically is that sine squared of theta plus cos squared of theta, the answer is always 1. And if I solve for cos squared of theta, I'm going to have cos square root of theta will be equal to 1 minus sine squared of theta. And this is what you see in the denominator there. I'm going to have that replaced by this expression. So basically we are saying that this integral then must change as follows. This integral should be equal to the integral of theta in the numerator all over the square root of cos squared of theta. And then we have cos theta d theta. Now taking the positive square root of cos squared of theta, this cancels that. And so what do I have? Well, what I have now is this integral is equal to the integral of theta all over, remember, cos theta, and then we have to say times cos theta d theta, that part. Now you'll agree with me that this cancels that. So what do we have now? Well, what we have now is the integral of theta d theta. Now I want to remind you of the power rule here. The integral of x power n is actually the integral of x power n dx is actually, power rule says x or n plus 1. We must take this divide, and then we have to add a constant if this is the only expression we are to evaluate. And so this is a power rule. Now applying that here, you'll agree with me that this is just going to be, remember there's a power of 1 here, we have to add 1 and divide. So it's going to be theta to the power 1 plus 1 all over 1 plus 1, and then I have to say plus c, because our integral does not have limits. It's an indefinite integral. Completing this on page 3, we have the following information. Completing it on page 3, we have the following information. Let me move this one down. Right, now, what am I saying? I'm saying that, right, I'm saying that if you call this page 3, we have that expression being equal to theta squared over 2 plus c. Now we have to revert to our original variable. What is the connection between theta and x? Because that's x. Our original variable is x. Looking at this equation here, you'll agree with me that theta equals sine inverse of x, or arc sine of x. So where I see theta, I must put arc sine of x or sine inverse of x. So our final solution then is going to be equal to, in the numerator, I have sine inverse of x, and I have to say squared, because remember we have a square there and we're supposed to divide this by 2, and then we have to say plus c. So this is the final solution to our integral. Just to remind you, the integral we've been evaluating is this one here. This one. This is the integral we have been working on. The integral of arc sine or sine inverse of x all over the square root of 1 minus x squared dx. All right, I am going to stop there. In this one, like I said, I prepared only one integral here to work on. I hope you found that useful. Your feedback remains very vital to us, because it helps us to plan on how we are to present information on this channel to help you and many other students. All right, I'll see you in the next one.